Okay, good morning. All I want to do now is to continue on the idea of magnetism and where this idea for motorization may come from. Now, this is just some information I've picked up from my own lessons in presentation and using information provided by someone called K.A. Connor. Okay, now obviously this was done some a while back. Okay? And here you simply have one of the first compasses of fish-shaped iron leaf was mentioned in the Wu Qing Song Yao written in 1040. Now, what the heaven's name that is, I can only assume that it is some kind of text, Chinese book, okay? But purely for information only, okay? And here we have what we may call animal magnetism. A fox suspended in an intense magnetic field, all of us are paramagnetic. Much money is wasted on magnetic therapy. Okay. Again, here what we're just showing you is that someone have the idea of suspending a frog in a magnetic field to see whether or not it would rotate. But as our body consists of some electrical impulses anyway, that probably would happen. And here we have magnetic attraction, okay, purely, okay. It's possible to produce motion using magnetic attraction and or repulsion. Either permanent magnets or electromagnets, or both can be used, okay. And again, just providing you some additional information that runs consecutive in regards of the motor videos I have already done. Here we have, okay, magnetic attraction repulsion, like poles repel, unlike poles attracts. Okay. Now here we have a DC motor. Now hang on, let me see if I can highlight this at all. Can I highlight this? Wait with me for a moment. Can I get some color into this? Would it give me color? Color? Nope. No, it won't give me any color. It's okay. I probably should have done this before I started the video. It's okay. I'm just trying to see if I could find some color. Color? Nope. I don't think it'll let me do it now anyway. But anyway, let's see if we can highlight the text. Nope. Can I highlight the text? Right, highlighters, nope, okay, oh, it was an idea, okay. Range, nah, sorry, it doesn't look like it's going to give me any. It's okay, probably should have done this before I came in, but it was an idea. Okay. Anyway, okay, I've just highlighted the text anyway. Right, the stator is the stationary outside part of a motor. The rotor is the inner part which rotates. In the motor animation, red represents a magnet or windings with a north polarization, while green represents a magnet or winding with a south polarization. Opposite red and green polarities attract. Okay. Okay. And again, here we have DC motors, and it's showing you that you have the rotor rotating in a magnetic field. So here's your rotor. This bit here is your commutator, okay? And that's your stator field here, okay, around. Let me see if I can highlight this so it's easier to read, I hope. I was going to try and put it in text. Now, I don't need to be reading this out to you because you can read for yourselves, okay? And it's here long enough for you to be able to read it. Okay. And here we have some applications for DC motors, okay? Automobiles, windshield wipers, door locks, etc., etc., antenna retractors, etc. And you'll find that a lot of these motors you can find on your car, which operates your windows, your rear and front windscreen wipers, the movement of your headlights up and down, so forth. Okay, your wing mirrors, excuse me, and etc., etc., etc. Okay. Now here's the Beekman motor. Now all this is saying here in regards to Beekman motor is that it's a simply made up constructed rough work purely to show how the motor principle can be applied. Okay. And here you have simple DC motor made with a battery, 2 paper clips, a rubber band, and about 1 meter of enamel wire. Now the enamel wire would be this here, and it's an enamel wire because it's insulated as such. So it allows you to create a current flowing in the circuit that creates a magnetic field that then allows you to rotate. Okay. So sorry about that, I clicked the wrong thing. And here we have a brushless DC motor, okay? And again, I'm just going to highlight this so you can see it in hopefully make it a bit brighter or so that it stands out. And again here, I'm not going to read this to you, you can read this for yourselves, okay? And but what this is showing you the principle as to how a brushless motor works, okay? It purely works on permanent magnet effect. Okay. I'm staying on this long enough so that you can read it for yourself. Now remember, you can use a pause. Now look back also at the motors I've already done in regards to videos I've done in regards to motors, and look at the electrical principles playlist as well. Okay. And again here you just have a further extension of brushless motors showing you how it can be used, and that it can be used for artificial hearts, tape drive, etc., winders, etc. Okay, again for you to read. Now also do some additional research on Google in respect of DC motors, because there's a lot of information you can find from there as well. Okay, and look at the calculations in regards to the frequency and pairs per poles. Okay, it is relevant. Okay, and again here again you have full stepper motor. Okay, and again here I'm going to leave you to read this for yourselves. Okay, it is quite self-explanatory. Okay, and let me just try to highlight this again. Okay, I click on something and it just will not go off my screen. Okay. Now, the rotor of a permanent magnet stepper motor consists of permanent magnets, and the stator has two pairs of windings. Just as the rotor aligned with one of the stator poles, the second phase is energized. So it's a continuous rotation. Okay. Now remember that this can also be applicable in three-phase as well. Okay. Hello? Okay, can you just call her back in 15 minutes or so? Yeah, okay. Sorry about that. But these things happen at the most inconvenient time. Okay, now again, read this for yourselves. Okay, do some additional research and get that information in. Okay. Half stepper motor. Yes, half stepper motor. Okay, right, sorry about that. Right, let's see if we can highlight this again for you. Okay, so we can bring it into a better visual, hopefully. Okay. And again, read the information. I don't need to read this out to you. Okay. And again, let me just pick this up for you again. See if I can highlight it. Okay. Again, hopefully the idea here is to simply try to make it easier to read. Okay. And I'm hoping that works. I probably should add color to it overall, but we'll see how it runs for now. Okay. I'm just moving so you can see that. Okay. And I'm moving to here as well. Okay. Sorry about that. Okay. I'll pan back. Okay. Okay, good. Now here you have a more on stepper motor, and simply showing you how the stepper motor works. Okay, basically. And let me just go in here closely so you can see that the polarity of each coil, or in respect of each pole. And here you can see that you have a 12 pole situation here. Okay. And here is showing you simply how the controls is being applied in regards to your transistor control systems. Now do some additional research on this, okay, so you can see actually how the electronic system has been used to control the motor more efficiently. And let's do just going it, okay, and again more on stepper motors. Now here is your main supply, okay, that's your positive source. This is your source going to the neutral or ground if you prefer, and it's simply by bringing in each switch in turn that allows you to control and allow your motor to function as such, okay. And again, this would be your rotor, that would be your stator, okay. Now here we are again, okay, and again this is to do with brushless AC motors. And again, all I'm going to do is highlight this again to make it easier for you to read. Okay, you don't need me to be reading this to you at all. You now do some additional research as well. Make sure you can find information you want in regards to brushless AC motors. Look at their construction and how they're made, both for AC and DC. Okay, because there's some new methods being applied now in motor construction, which makes motors very small and efficient. I mean, look at your drones. I mean, can you imagine the technique now being employed in using the motors that we are now using in drones? I mean, and you have to remember that drones only came about from a movie idea, but yet it's now become reality. Let's hope too many movies don't come to reality, okay? Because right now we have this situation with regards to coronavirus, and that's not a very good one at the moment. So let's have a look, and hopefully we can overcome. Anyway, this is for you to keep in mind and to read. And again here, what I'm going to do is highlight this. Hopefully I'm making it to an AC induction motor, okay. Now again, look back at the videos I've done on motors themselves already, okay, and this now gives you a bit more insight into and knowledge. Hopefully do your own research, do additional research, do not just read it from here, okay. It's more, this is only a snapshot of what is available, okay. Do not take it as read. And here we are again, okay, continuing with that, with induction motor. Let's see if we can highlight this for you to see. Hopefully it will make it more clear to look at and read, okay. Okay, let's go back a little bit. And here's a huge list of applications, okay, and this list is even larger now than it was then at that time, okay. And all I'm going to do is just go in a little bit and give you some ideas of the listing required. pan back a bit, okay, slowly. Okay. Now, hope you found this useful, okay? So have a good day, and bye for now. Okay, thank you.